All right, so first off, we'll just cut to the chase here. This graph is a terrible looking graph. It did not replicate very well on a copy machine, but that's okay. We're gonna work with it. I know what a better copy looks like. So we see that from the scatter plot below, what would the equation be for the line of best fit? So when you're looking at something like this, you're kind of doing an eyeball. So if I'm looking at something, I'm trying to eyeball this and trying to figure out how to get a line that best suits what we have going on here. So I have this really one high value, but for the most part, this is pretty linear. So what I'm gonna do is I'm going to sketch what I believe to be a decent enough linear equation. And I think I'm gonna do something similar to this. So it does not, when you're doing a line of best fit, it does not need to touch all the points. I think a lot of people think that they need to connect things always, but this is about a pretty decent looking, I think, fit for all of it. Again, it's pretty far off from that last point, but that last point seems to be an outlier here. So if I'm looking for the line of best fit and I want to find the equation for it, I would start off by looking at right here. So basically, if I'm looking at this line right here, I'm thinking that it's maybe about looks like about 116 the way that I drew that. So my y-intercept would be 116-ish. Now, it might be a little bit off there, but that's okay. All right, so we're going to do y equals, and I'm going to put at the end plus 116. That's my y-intercept, so we're going to start there. Now, it's a linear equation, so we're going to put x right before that plus sign. And so we need to figure out the rise over the run. So I'm just going to put a fraction, put that in there. All right, so now what we're going to do is figure out 2 points on the line. So we want the line, not the points that we have there, and kind of see if we can find something that works pretty well with it so that we can find out what the rise and the run is. So if I look at where I have, looks like 120 is kind of matched up with 2. So we're going to stick with that one. And then let's go with maybe, there's 130. It's not really that great. How about right here? Let's try to do 4. Okay, so 4 would be about there. And so we're going to just kind of line that up to where we, looks like about 120, maybe 126. All right, so this is about 126 right here, and this looks like at 120. So basically, my rise would be from this point to this point. How much did I go up? So if I went from 120 to 126, that is an increase right here, or my rise would be of 6. And then if I go over, I went from 2 to 4. So that is 2. Right, so it goes over 2. And so my rise would be 6. My run would be 2. And so I could reduce the 6 over 2. So 6 halves would just be y is equal to 3x plus 116. So that's my guess. And again, that's just a rough estimate. When you're doing this and you don't have the line and you have to try to figure it out and eyeball it, especially in a question like this, if you have, most likely you'd have a multiple choice question like this. But if I was trying to get a close idea of it, that's my idea of what it could be. So I would be looking for something that's very close to that, primarily starting with the y-intercept, going with the 116, and trying to find a y-intercept that would be relatively close to that number. And then also working off of the slope to see if that would help me as well. So that's what I think is my answer, but I'm going to double check this again. I know what this graph really looks like, but either which way, these numbers are not 100% definite because I don't actually have the data table that goes with it. So I just basically made my own data table. And again, this answer may not be exactly what, the choices might be, but you'd be able to get a really good estimate to help you with figuring out what the actual answer is on this question. So as you can see from this terrible copy, what I did was I went into Desmos And up at the top, just so you can see, if you go into this plus button right here, and then you hit table, that's how I got this table that you see right there. So I entered all the data points in, so there were 18 data points. So I listed them 1 to 18. And then again, I took what I believed to be the best idea of what each of those numbers actually were on this table, or on the scatter plot. Now, if I want to find the line of best fit, I'm going to go down to box 2 underneath it, and I'm going to type in Y, and then I'm going to hit the 1 and see that the 1 becomes a subscript. And then I'm going to hold the shift button, and I'm just going to show you right here. See this little squiggly line right here? I'm going to hit that when you hold the shift button down, and you can see that it makes a little like tilde that you use in Spanish. So you have that little like squiggly. And then you're going to do the linear equation is mx plus b. So we're going to do mx, and then I'm just going to type the number 1. And the 1, again, it becomes a subscript. And then I do plus b. And then I get my statistical analysis. So according to this information that I put in, my y-intercept here is actually 118.485. My m, or my slope, is actually 1.90749. So it's just approximately a slope of 2. I had a slope of 3. And I'm just going to write this down. So this one is saying that my slope is we're going to call it 1.9x. And then, like I said, the y-intercept, or the b value, is 118.5. So this was 118.5. So, I mean, I was off but my drawing, but I wasn't like horribly off. But you can see that now I've got like an idea of what my choice should be around. So that should help me with solving this question.